Hello everyone, this is Benjamin here, and today I'll be going through basic dynamic analysis for our malware Google Adobe Flash Player. So basic dynamic analysis involves running the malware and observing its behavior on the system in order to remove the infection and produce effective signatures. Yeah. Okay. So for basic dynamic analysis, these are the tools that we're using. MAAT DNS. This is a tool for helping to manage DNS responses by listening on the UDP port 53. You can track DNS requests made by malicious software, and you can also trick the malware to send its traffic to the host. Okay, this is netcat. Alright. Netcat. Okay. So what is netcat about? Netcat, it reads and writes data across TCP or UDP network connections. So it can be used for inbound or outbound connections, such as port scanning, tunneling, and port forwarding. Process Explorer. So this is an advanced process management utility. It will show you detailed information about process, including the command line, full image path, the security attributes, and so on. You can also list the DLLs that is loaded or the operating system resource handles it has opened. Yeah. Okay. Still have I still have Ragshot, which is an open source registry comparison tool, which allows you to quickly take a snapshot of the registry and then compare it with another one to report on the difference. And last but not least is a process monitor. Okay, so process monitor, this is an advanced monitoring tool for Windows, which is able to show real-time file system, registry, and process. This is a core utility for system troubleshooting and malware hunting toolkit. So I'll be taking the first shot first, which is the clean shot, where I did not run the malware yet. Yeah. Okay, this will take a while. Right now, before that, so I'll be using this loopback address 127.0.0.1 so that I'll be able to receive the reply. Okay, server setup, right. And right now, it's time for me to run the malware. Before that, I need to change directory to my netcat. Okay. Alright, so now I'll be able to Where to listen to port 80. Okay, so I'll leave this here for now. And I'll have to run the malware right now, which is Google Adobe Flash Player. So as you can see, the malware is in the Process Explorer, as I've just run it. So I'll be taking a second shot. Alright, and now I'll compare.
Right, so this is the screenshot of the shop. So as you can see, there are 6 values being modified. So firstly, for the first one, use cryptography RNGC. This is a seed for a cryptographic random number. So generally there are 2 ways to generate seeds for random numbers in cryptography, which is using hardware and software. So in this case, this appears to be using for the software-based method. The cryptographic service providers are able to use this when generating a password hash. The purpose of this registry being modified is unknown, because none of these interactions with the registry seem to be of much importance and were mostly used to set up imported DLLs. For the next one, the scheduling agent last task run. This is being modified to ensure that the Trojan gets installed with compromised machine and executes upon system boot. And for the other registries, they are associated with the configuration data of the DHCP. So apparently this malware is trying to modify the configuration of the DHCP. It might be a DHCP server spoofing. So right now I'll be moving on to the process analysis, which is making use of the Process Explorer. Alright, so
The Process Explorer, here is the malware, Google Adobe Flash Player. So I will have to suspend this malware first. Alright. As the malware might just disappear from the Process Explorer as it will be running in the background. So as you can see here, let me view the DLLs first. So here are the DLLs of our malware. Okay, wait, DLLs. Here's our DLLs of our malware. Correct. And also, you will be able to see that our handles, there are mutants being created. So it's a mutex. So a mutex is a program object that is created so that multiple program threads can take turns sharing the same resource, such as access to a file. So going on to the properties of our malware. So we are unable to verify this image file, most likely because this Windows process is not legitimate, but malicious or unsafe process. We are able to see that these are the threads being maintained by the malware while running in the background. So now I will open the Process Explorer. process monitor. So in this process monitor, I would filter two six seven six P and 2676. Apply. Right, while this is loading, let me just explain to you what are the results of the updated DNS that we've got. So updated DNS is monitoring the DNS request. So we're able to see that there is this wpad.local domain being requested. The wpad protocol allows automatic discovery of web proxy configuration and is primarily used in networks where clients are only allowed to communicate to the outside world through a proxy. So the malware I'm trying to make use of wpad attack, which is usually performed on the network segment. Also, there is this. This is possibly trying to edit the configuration file to perform a malicious action or compromise the system. Alright. Alright, so here's all the process for malware. You'll be able to see that there's a lot of operation red file. So it can be seen trying to edit the user's preference file in Mozilla Firefox. Right, there's also the red close and red query value, and also red open key. So you can see that the malware is trying to edit the registries by opening specified registry key and retrieving the data. So I'm done with updated DNS and the process monitor as well. So I'll just close this first. So moving on to netcat. So for this, I'm going to open another CMD, scene here, and I would run the command next that. Okay, so this is the various active connections as you can see. So there are 4 different TCP connections right now. Just to make sure that the netcat is running, you will open the task list. Okay, and you can see netcat is here. So indeed, it's running now. So I'm done with netcat 2. So this marks the end of my basic dynamic analysis on our malware Google Adobe Flash Player. Thank you.